Alrighty, this is Tommy Reed. I want to give you a little update on something very, very important I've been working on. This is basically a very unique power station. This uses liquid as a liquid piston. In other words, there is no mechanical piston, there is no mechanical crankshaft or piston rod. But I want to show you where I'm at on this. This is a power system that actually is a hybrid. And what it does, it actually has a system. Right now, I'm going to show you with just a 12-volt battery because it's how it's going to eventually start. And I'll go through some of this real quick and some of the details that has to go on. This is basically a pump. This actually is controlled by the motor. When that turns, it starts building up pressure. It goes into my accumulators. Those accumulators are going to generate some pressure that then gets fed into my gear motor, which is also part of the alternator on the other side. Let me show you. And that's part of the alternator. And basically we have a turbine in here, almost like a Hero turbine, a little bit more advanced. Right now I'm not using that because that's for a much higher pressure. But I want to show you where we're at. I want to start this up and so you can actually see the what's going on in the system. And I just do a little quick, just running it basically. And it has to build up pressure a little bit. Once it gets up to pressure, you'll see exactly what's going on in this system. And I could tell if I'm starting to build pressure because my amps are going to go up a little bit, as you can see. We're running about 12 volts, 12.5. You can watch the amount of pressure is coming. It's starting to take off. It's going to bring down the amperage, of course. And running about maybe roughly, probably around 100, maybe not even that, probably about 50 pounds, 60 pounds of pressure, which is steady out to about 700 RPMs. No load on the alternator yet. That's not the main part. When it puts it under a load, it actually does something and the pressure goes up much higher. And we're going to pull about 20 amps on that. But everything else, this is all running nice and smooth. Basically, this all goes back fluid, goes back into the reserve tank. These are just my bleeders, but the accumulators are actually stayed very cold because they're actually pulsating continuously on this. So it's actually pretty interesting technology on this. And this is running very, very smoothly. When I put it under a load, let me see if I put this under a load. So you can see the amount of power that it actually starts to pull. Let's see. And I think we got one there. I got to hook it up to the battery. So I can actually run this at a very low RPM if I need to. Let's see. And hook this one up to here. That energizes my field, which I want to do. It should energize my field. Oh, okay, right here. And you can see it's starting to really bog it down. But what's going to happen is that the pressure is going to build up. We're pulling some more power. We got power output now. So we're running about around 300 PSI. Not bad. But I'm pulling a big load on the alternator, which is a 200 amp plus. And basically, let me turn this back off. You can see how the RPMs are going to just rev right up. It's going to run about 1,000 RPMs. Pretty much, I'll let it. I run this continuously to make sure there's no leaks and stuff. But I want to show you what this is really about. I want to keep this running because this is just the beginning part. I want to show you something extremely important, what I've actually designed. And it's the first liquid piston. That means there's no mechanical piston in here. And this is my testing right here. Now this is a liquid piston engine. Basically, it moves hydraulic upward into the pump. And it causes a four-stroke motion. So it goes up and down like a regular piston. It's just using liquid, so it never wears out. And basically all these valves, I'll show you, I have a manual and then I have to also run it by the computer. But this allows my exhaust to open up. This allows my intake to open up. That pulls in propane and air. This is my spark. And all this stuff is all added. And actually there's a little gas in there. You heard a little pop. And this is the motor itself. That engages the motor. Now what I'll try to do is show you some what it actually does. Let me plug this in. It is programmed to a point, and this will go through the function, and this is basically what the screen is going to pop up. It's loading. So there's my hydraulic system and how it's actually working right now. The fluid is going to start pumping up. And what it does is actually filling inside the chamber right here. So when it goes up to a certain area, I end up timing it to get a pretty good idea. And it's saying right here, exhaust open, which it is. It's pushing all the excess gas, pulling it back down. At the same time, this is opening, pulling in the air and fuel mixture. And then it's going to close and then do the process of, let me just bring that, I don't want it to compress because I got the valve open. And basically it's doing the intake, closes, now compression takes place. That's when it's actually compressing the fluid into the combustion chamber. And from there, it will go through the next process once it reaches a certain point. And then you're going to have detonation, which controls the spark. So you're going to see the, I got it running really slow, which is really good because it gives me a pretty good idea of what's actually going on. And then the spark will start to happen, and all that is working really well. So it goes through the same process again. So this is pretty much where we're at on this process. To get it to actually fire, I hope to show you the firing. It's very violent, but at the same time, it's also very powerful. We're using a stepper motor to actually control the up and down movement. It could be a lot faster, but even at one time per minute, I still have a combustion, which is really excellent. And that's the main point about this whole liquid piston or hydraulic combustion engine that we're having. And you can see we're still running this, no problem at all. Everything's running the way it should. Pretty much I'm only pulling about 9 amps. This is a waste of energy right now because it's not really doing any work. But once I get in that combustion chamber inside the system, we're going to be building up pressures between anywhere between 5 to 1,000 psi with the combustion chamber. So this is pretty much the update on this build. It is a hybrid. That means the power generator actually produces the power to keep the battery bank charging, and then run either a 1 or 5 kilowatt pure sine wave inverter, depending on the load. But this is only going to be about 1 kilowatt. But the amount of energy we're going to be using, think of fuel consumption. Even if I fire this every 10 times a minute, that's far less fuel than any generator out there when it comes to a 1 kilowatt output. So this is pretty much an update. Everything's running really well. I had to make all these sprockets, so I'm hoping they wear in really good. It seems like they are. This is identical pump, so I matched up the pump, so I know where I'm at with that. Other than that, I think it's actually going to be pretty cool when it's finished. Had a lot of leaks, you know, it always happens. So I'm dealing with cooking oil as a hydraulic, because cooking oil can actually hold its viscosity under even extreme heat, you know, much better than any oil or hydraulic fluid. And it's also environmental friendly. So this is a hybrid natural gas. It's a complete hybrid system, off the grid power system that can use even gasification, natural gas, propane, anything, even hydrogen or an HHO if you need. So I hope you enjoyed this video, and I will talk to you later.